The next topic we're going to cover is trigonometry for non-right-angled triangles. So the first thing we want to do is just revise that right-angled trigonometry, or SOHCAHTOA as we know it as. So the first question here says, an aeroplane takes off at an angle of 18 degrees as shown below. Calculate the height, h, the aeroplane is above the ground after it has travelled 850 metres. So my starting point is always to label my triangle. This is my right angle, so directly opposite I have the hypotenuse. Here's the angle, and directly opposite that I have the opposite side. So then the final one left over must be the adjacent. Now I have SOHCAHTOA to help me decide which ratio I'm going to use. So I have the hypotenuse because I'm told that that's 850 metres. And I'm looking for the opposite, since that is the other side that's been labelled h. Now I can clearly see that I'm using sine, and as a reminder, sine x is equal to opposite over hypotenuse. Now I can fill in all my bits of information. Sine 18 degrees is equal to h over 850. Because I want to isolate the h, and at the moment it's being divided by 850, I'm then going to multiply by 850 to get that h is 850 times sine 18. And as much as possible, I want to take these answers to 2 decimal places unless it states otherwise. So that's 262.66 metres. So that means that this plane is 262.66 metres above the ground. Okay, we've got another example here, and this time you'll notice that we have in fact got an angle this time that's missing. Okay, but we still start exactly the same way. We're going to label our triangle. So right angle is here, so opposite that is the hypotenuse. There's your angle, and opposite that is your opposite side, and then your final side is your adjacent. SOHCAHTOA says that because we have the opposite and the adjacent, we're using tan. And then as a reminder, tan x is equal to opposite over adjacent. So if I substitute in my values, I have tan A is equal to 5 over 3.2. Okay, and we're trying to isolate A this time, and A at the moment is part of this ratio tan. So to isolate A, we're going to have to take tan inverse of 5 over 3.2. And again, to be as accurate as possible, we want to take this to 2 decimal places unless it states otherwise. So it's 57.38 degrees. And then finally, we have an observer at B, and he sees an airplane drive directly overhead. The airplane has taken off from point A and has flown 1,650 metres. The angle of takeoff was 8 degrees. Calculate x, the distance the observer is from the takeoff point. So again, we're starting by labelling. There's our hypotenuse. There's our opposite. So that must be our adjacent. Writing out SOHCAHTOA. Okay, I have the hypotenuse, and x is the only other, A is the only other side that's been labelled. It's been labelled x, so then I'm using cos. And then cos x is equal to the adjacent over the hypotenuse. So we have cos of 8 degrees, and that's equal to x over 1,650. At the moment, I'm dividing by 1,650 because I want to isolate that x, so x is going to be 1,650 times cos of 8. And then again, to remain as accurate as possible, we are looking at the answer being 1,633.94 metres. So this observer is 1,633.94 metres away from the takeoff point.